Hey, I think we're live now. Oh. Perfect. Can you talk there, Nikhil? I can't hear you. Can everyone hear me?
I think you can hear me now.
Oh, yeah. Yeah, I can hear you. Perfect. All right. Get Sasha here too. Get him talking.
Hey, I can hear, but my camera doesn't seem to be working. Just a second.
Okay. Yeah, thanks for the last minute scramble. There was just a confusion with the timing, everyone. Miscoordinated. But we'll get it going. And Nikhil will talk about WASM smart contracts and interacting with them with astar.js here shortly.
Yep.
Hey, here I am.
Let me.
Hey, all.
And for anyone who's what you would be about on time, but an hour after this is being broadcasted, it's all recorded, so you can follow through afterwards.
Can you see my screen?
Yeah, I can. Yeah.
Nice. Yeah, let me know when to start.
Go for it. We won't waste any time.
So yeah, hello guys. Welcome to Astar Tech Talks. This is chapter 7, how to interact with WASM smart contracts using astar.js and Page V2. So today's agenda is Astar Network and introduction to Astar Tech Talks. Next is WASM smart contract using Inc language and how to interact with WASM smart contract from dApps using astar.js. We have some demo for you, and at the end, some Q&A. So Astar Network is future of smart contract for multi-chain. Astar Network provides the Innovation Hub for smart contracts. So you can build your smart contracts using Solidity or in WASM using Inc language or Ask language. So WASM smart contract empower developers. Developers can build complex dApps, use familiar language, and directly access the runtime to an extent, substrate runtime. And developers can build dApps that is not possible with EVM with WASM. We also have a dApp staking model. So in Astar Network, user can directly support projects by staking on them, which will become a passive income for the developers. So if you build on Astar Network, you get to earn money. So that's a good thing for all the developers here. And dApp staking encourages projects to stand out and provide value directly to end users. We also have XVM, cross virtual machine. So cross virtual machine allows developers to call smart contracts from one VM to another, for example, from EVM to WASM and WASM to EVM, and build unique features like that. So this features is only available on Astar right now of all the parachains. So what are tech talks? So it's from developers to developers. Me and Sasa both work as a developer at Astar Network. And this is basically deep dive for technical topics and Q&A from community. So we enable developers to build powerful dApps on Astar and Cider Network. So for those who don't know what are smart contracts, let me provide a brief summary. So me and you have normal wallet in a blockchain where we can send each other funds and tokens. Smart contracts are special wallets. So the funds at that wallet is controlled by a code, the code you write. Also, nobody has the private key to that wallet. where a smart contract is deployed. This is a feature, not a bug, because you don't want any admin to like be indecision of how the funds will be used. So you can build trustless systems like DAXs, lotteries, and marketplaces, and so much more using smart contracts. What is astar.js? It's a library from Astar Network. So astar.js is one-stop shop for developing front-end or even Node.js dApps on Astar Network. It's a TypeScript SDK, which includes library for connecting to Astar node. It includes proprietary types for Astar, Haydn, and Shibuya networks. It also contains various utility functions necessary for working with Astar dApps. And a developer can easily set up astar.js for querying the blockchain and sending transactions to the blockchain. Setup process is simple. You have to have Node.js 18 plus. You have to have yarn. You create a directory, set up some Node.js scaffolding, and install Astar API, Astar Network / Astar API. All these links is given in the slides, which we will share later in the presentation. You have to import the options from Astar Network Astar API. And when you are connecting to the node with a provider, you just pass option before the provider in an object into the API promise class. That way you get all the proprietary types for Astar Network. So the sample WASM dApp we will be working on today is WASM lottery. This is a fairly simple lottery contract written in ink. You can check out at swanky.dApp/WASM lottery. So this was created by Swanky CLI. You should also learn about Swanky, which is also a tool and Swanky tool from Astar Network, which is used to create dApps and scaffoldings around it. So WASM lottery contains this folder structure where contracts lottery lib.rs. This file was initially generated by Swanky, and then I changed it to include to write the code for the lottery contract. So this lottery contract contains some transactions, functions, messages, ink messages. So the most important one is you have to enter into the lottery and somebody can pick winner. So anyone can enter into the lottery with any value they have to give to the smart contract. And if value, like if you don't send any Astar token to it, then it will throw an error. And if you send some Astar token when calling the enter function, then you get entered into the lottery. And it indicates the event that a player has been entered into the lottery with some value. And then anyone can pick a winner after people are there in the lottery. So it is using a pseudo random function. So don't use it in production. But using pseudo random, it generates a number from 0 to n, where n is the number of lottery players, and it picks one out of randomly and send all the funds to the winner, and that's it. So it's a simple lottery which you can deploy on Shibuya, Haydn, and soon on Astar Network. So how to interact with this lottery contract? There are multiple ways. So the first way, when you are developing your contract, you have to interact with using either Polkadot.js or Contracts UI. From Astar, we recommend using Contracts UI because it got a lot more features. So your lottery contract, you can deploy using add new contract and upload contract code. You can give your contract a name and upload a code bundle. So inside WASM lottery folder, there will be artifacts for you, which you can deploy. So the latest artifact, you can use .contract WASM bundle, and you can deploy this. And after deployment, you will get this UI, where you can call all the functions in the lottery contract. So first function to call here is start lottery, because this is written in the code that first we have to start a lottery. And we will talk about these value, ref time and proof size today. What are those? What is weights v2? And how to interact, like how to create your own UI so that you can interact. You can create buttons and interact using JavaScript, TypeScript. So I'm starting the lottery. It will ask for my signature. It's doing a contract call and providing some gas. My password for my Polkadot.js wallet. And soon the lottery will be started. Yeah, this is success. This has emitted some events. Now I can enter into the lottery with some value. So I can send any amount of Shibuya there. For sake of time, I will just demonstrate this enter function and not pick winner. But this is fairly simple, that you enter into a lottery, multiple people can enter, and one person will be chosen out of random, and whatever value you have sent, all the value will be sent to one random winner. So enter is a message, transaction message, and you can also check the states. So when I do get players, so I can see there are some players there. I think I have already entered before, so there are 2 players there, and I can pick winner. So this contract will send all the value to one of those players. Yeah, so it has chosen a winner and sent 2 Shibuya to the winner. So there are multiple things that is needed to like send this message to the contract. So I will describe that process. So first, I want to talk about transactions, weights, and fees. So when Ethereum was created, it solved a crucial problem in the computer science, that like whenever somebody write Turing complete contract code, like how to predict that this code will stop executing or not. So this is Turing problem of the computer science, that like you cannot know in advance that code will stop executing or not. And so to solve this problem, Vitalik Buterin of Ethereum created the concept of gas, that for every line of code you have to pay gas, and the user who is executing the contract method can provide some gas to it, and if like the contract used more gas than needed, then the contract reverts. In Polkadot world, like the gas is replaced with weights. So when transactions are executed or data is stored on chain, the activity changes the state and of the chain and consumes blockchain resources. Because the resources available to a blockchain are limited, it's important to manage how operation on chain consumes them. In addition to being limited in practical terms, such as storage capacity, blockchain resources represents a potential attack vector for malicious users. For example, a malicious user might attempt to overload the network with messages to stop the network from producing new block. To protect blockchain resources from being drained or overloaded, you need to manage how they are made available and how they are consumed. That's where the concept of weights come in. So these resources are memory usage, storage input and output, the computation, transaction block size, and state database size. So with the new release of contracts palette, weights v2 are being used for sending this weight, or you can say synonymously gas, to contract methods. So weight v2 include two parameters, ref time and proof size. For Inc and for ask as well, the term gas refers to the resources used by contract call. It is important for smart contracts that caller has to pay for any utilized resources. These resources can be either storage space for storing something in context storage or computational time for executing contracts and its logic. The term gas encompasses both of these resources, ref time and proof size. Gas or weight, you can say. So ref time is the amount of computational time that can be used for execution in picoseconds. And proof size, the amount of storage space that can be used in bytes. So ref time comes from reference time from substrate weight system, where the computation time is benchmarked on reference hardware. And you can read more details here. This link. For Inc, gas is synonymous to weight. We just use this term to make onboarding easier for dev and other smart contract ecosystem. Specifically, these terms come from substrate weight v2 system, which was recently introduced with new contracts palette. Yeah, so this is the concept of weights v2. You can learn more about this weights v2 in the link here and link below this presentation, which we'll share. So we have seen how to interact with the contract using context UI, but you have to build your own UI. So to build your own UI, you have to connect to the node first. So to connect to the node, you import some libraries. Most important of them are API promise, WS provider, and also astar.js options method. And you just connect to the node and get a API promise class instance back. This API promise class instance will be used to interact with the RPC node. You can send transaction and you can query data from this RPC endpoint or any Parachain RPC endpoint, Sidon or Astar. Here in this case, we are using Shibuya. Then you have to connect to your contract. So in the artifacts folder, other than .wasm file, there is also a JSON ABI. This ABI describes all the methods and events that are in the contracts, and that is needed in the next step for connecting to the contract. So you include ABI and contract promise classes from API contract. You include your lottery JSON ABI, and you instantiate contract promise with the API defined above, ABI, and the address where it was deployed. So you can also deploy your contract using several ways, using Polkadot.js, using Swanky CLI or contract CLI itself. It will give you address that this is the address where the contract is deployed. Next thing you have to do is, you can query contact methods, which just provides some data and does not manipulate blockchain state. This and transaction both require some gas limit. This gas limit you have to fetch. So to fetch this gas, which V2 gas, you can use API const.system.blockwaits. So this you can get from Polkadot.js or this API promise class instance. So max, like this provides many different types of weights, but max block will do for your purpose. Also in Polkadot, whatever gas is not used is refunded. So it's not like that you can set more. Like you don't have to worry about overpaying for gas in Polkadot. So gas limit you provide, and it will give you a result and output, which you can show in the UI. For sending transactions like enter or pick winner, the process is more complicated. So for sending transactions, first you have to query the transaction method as query. So with this query, like the transaction will not be called, but it will return you a gas required and a result. So gas required you can use to send to the transaction method later, and result you can use to throw errors if there are any. So this is kind of a dry run for your contract method. So this dry run will help you check for errors. So you can check if that result.isError is true. If it's true, then there will be an error. So you can use this piece of code, which is given in WASM lottery GitHub repository, to check for error and then throw the error, so display the error to the user. In some other cases, when contracts will get reverted because of some assertions, result is okay. But if the contract flags include revert, then also this will be an error. So you can get the exact error using ABI registry, create type unsafe, type name, this piece of code, and show the error. Now after you have handled the error and the error did not occur, then you can call the transaction. So to call the transaction, you have to provide the gas required. You returning previous query step in the transaction as gas limit. And then you can call sign and send on a address. So when you call sign and send and there is a wallet installed in the browser will open the wallet and ask for user signature and will say that which transaction is being sent. And after transaction is finalized, you can show you successful message. So this dApp is given in WASM lottery contract, and I have created this using Swanky CLI and create React app. So with Swanky CLI, you can do Swanky init to create your own project, which will create scaffolding for you. And with create React app, you can include the React TSX files, TypeScript files, so that you can show your UI. So I created a simple UI for this in React. So this UI shows like this, is ask for your wallet and you can play. So I think I can enter using play now button. So there's not enough balance here. Yeah, this asks for my signature and it sends the transaction to the contract. So the gas required will contain the ref time and proof size for you. This you don't have to calculate, you can get from dry run. So I will not send because this will fail because I am already inside the lottery using Contracts UI. So this is a long process. So to simplify this, we at astar.js has also created a helper function for you, which you can use to reduce lines of code. We are doing all the reward check and error check for you. And you just have to import this send transaction from astar.js, Astar SDK core. And you have to provide the API, the contract class. You have to provide which method you are calling from with sender address and how much value. So this is 1 and 18.0 because the decimal point of CUI is 18. And then in the result, you can just call sign and send. And this await function will throw the appropriate error for you. So you can catch error and display in your UI. Yeah. So that concludes the demo for sending and querying transaction. Next is Q&A. So I'm ready for your questions, guys. So if there are any questions, you can ask in the comments.
Yeah, I don't see any questions in the Q&A. Someone, was it Douglas, he did comment, maybe you can speak to that a bit. It's he asked, was it just to clarify, astar.js is a JavaScript library or a framework? Pierre said yes, but maybe the audience would like to, that explained a bit.
It's a TypeScript library, and it contains multiple node modules. So, it's a suite of astar.js is a suite of various libraries. So astar.js repository is in Astar Network, Astar.js, and there are multiple packages which corresponds to multiple different NPM packages. For example, Astar API, SDK core, precompiles, type definition, types, etc. Astar API is used to connect to the node, and SDK core can be used to import utility functions. Yeah, this is Astar.js. All these links are at the end of the slide, which we will share. Any more questions?
Douglas, he's got another question there. I can read it out. I'll read it out. Can the gas price be arbitrary, or is there a benchmark that needs to be considered?
Yeah, so gas price is not arbitrary with WageV2. So to get the initial gas, you have to call API const system dot block weights. So this provides various kinds of gas for your uses. So there is normal, operational, and mandatory. So normal, mandatory means this is the basic gas that must be sent to execute the transaction. Operational means if you want to do fast transaction, and normal means if you want to do average, you want to execute a transaction with average speed. And these value, this max block is good for any developer because the not used gas is returned in case of substrate. So you can use this value. And the idea behind sending transaction is that you should not calculate gas yourself, but you should use the gas required written in the dry run when you query the contract. So you should use this value and not calculate by yourself. This gas will not this gas required is good enough for any developer use case. You can say you don't have to go to the exact value on what the value was. I hope that answers your question.
Hey, could you just repeat that last line there? Yeah, you're breaking up a bit there.
Yeah, the gas required is good enough for developer, and they don't have to know the exact values, like the arbitrary value of what was the gas value. You just use values from returned from the API itself.
Awesome. And there's another question here in the Q&A. Thanks for putting in the Q&A. Do you recommend using the Swanky CLI to contract deployment versus substrate tools? That's kind of a good question there.
Yeah, I think Sasha can take this up because Sasha is the developer behind Swanky.
The Swanky guy.
Yeah, I mean, of course we recommend because we built it. So, but it's supposed to help you out with like removing the complexity, basically, like making it easier and more like straightforward. Just like Nikhil mentioned, you don't have to know the exact values provided, and Swanky aims to abstract that away. So like you just you don't have to fill it the file. You just name the contract you want to deploy and stuff like that. So yeah, definitely do recommend. And if you tried it, like it's only going to get better. I can promise you that much.
Nice.
Yes, it does, Douglas. Well, I mean, I can't claim that it includes everything, but includes as much as you need, to compile and deploy and call your contracts and test them. And what else? And a lot more. I'm currently like updating all the documentation, so it's gonna be like even easier to dive into that. Stay tuned; it's gonna be up soon. And if by substrate you mean like a cargo contract crate, then that's actually included into Swanky Dev Container that we also support. It's like encapsulated container environment that has like all the dependencies you need to use to develop smart contracts and to use Swanky inside it. I hope that answers the question.
Yeah.
Awesome. Yeah, thanks for the questions there. Makes the presentations a little more exciting when you have deeper questions to get away. I don't exactly know everything that's happening on Swanky, but I can tell you that there's a lot of plans to make it easy on Polkadot in general and Astar to build a little better. But it's a lot of work and testing. Oh, perfect. I was going to share that, Nikhil. Maybe you can introduce the forms there. That'd be great.
Yes. So while we are developing like astar.js and Swanky, so we have a developer survey for you guys. So we want you to answer what features you are using astar.js for and what you wish astar.js should provide or improve upon. So if you can fill the survey, that would be very great, so that we can better serve you and improve astar.js for all the developers. Link is in the chat.
Perfect. If you have any other like sort of questions, I don't know if there's a feedback section there, but any sort of feedback's great. So you can leave it there, and then we'll answer you, which is great. Well, there's no more questions from the audience, so I think that's a good spot to stop.
Yeah, and here is the link for the slides and all the links to WASM lottery contract, and the sample projects are here with the docs as well.
Okay, so the Swanky GitHub install link is in that document that you just sent?
Yep. No, this is the slides presentation.
Okay, perfect. And if you guys are later on also looking at watching this and you have a question or something, just hop on the Discord. That's usually where our team is, and we'll answer. And if someone doesn't answer immediately, they'll grab Nikhil or Sasha to hop in and answer the tough questions.
Of course.
All right. Awesome. Okay. I'll close the space there. Thanks for coming, everyone.
Thanks, everyone.
Thanks, Jared. Thanks.